Write down practical 1. Determination of determination of relationship between pressure and absolute temperature. This is called pressure law. Verification of pressure law. Pressure and absolute temperature. Right. Now we make easier again. Verification of pressure law. Right. Lazier again. Verification of pressure law. Verification of pressure law. Verification of pressure law. Right. First, let's take out the theory part. Right. What is pressure law? Verification of pressure law. Theory part है pressure law. What is pressure law? Pressure of an ideal gas, constant volume of constant moles of an ideal gas is proportional to absolute temperature. Right? Token pressure law again. Okay, in measuring. Right? We know for any ideal gas, TV over T is a constant. Right? TV over T is a constant. Pressure law is valid in constant volume. Right? Pressure law is valid in constant volume. When volume is constant, when volume is constant, right? When volume is constant, this is also constant now. P over T becomes K over V. This whole thing is a constant. If volume is also constant, right? This whole thing is constant, right? Which means P over T is a constant. Then P equals KT, right? Which means P is proportional to T. When pressure law, P is proportional to T. Right? How many pressure law again? You know? Right. Make that pressure law. Make verify karagane. Right? Okay. Now, as a theory, write this down. Right? Theory le agan. Ah, sexy lo gan. Ah, ha. Alright. Ah. Sadilları. Arre. Ne extra? Extra? Sadilları. Right. Oh, maybe. Right. तो बैठिए मैं बैठा करने राइट लिया करना ताऊ ना Okay, listen. As an experiment, what we are doing here is a simple thing, right? As an experiment, what we are doing here is a simple thing, right? Listen. පොඩි apparatus එකක් තියෙන්නේ. මෙහෙමයි වෙන්නේ. Listen, this is a beaker, right? Filled with water. This is kept on a tripod or a stand, right? And this is called a round bottom flask, right? There's a reason to be round bottom. Why it is must be round bottom, right? And this is a capillary tube. For this capillary tube, a pressure gauge is connected. For this capillary tube, a pressure gauge is connected. For this capillary tube, a pressure gauge is connected. Right? This is filled with water like this. And to change the temperature, we have a burner here, Bunsen burner. Right. Now, simply what we are going to do here is this. Listen. Right. Listen. Now, inside this flask, round bottom flask, right? Inside the flask, if we are not opening from this point or this point, there's a constant amount of gas inside, no? Right? Because in order to prove this, we have to have a constant volume. Right? And volume එක වෙනස් කරන්න බෑනේ. Volume එක වෙනස් කරන්න බෑ. ඉතින් volume එක තියෙන මේක ඇතුළේ. Now the gas is inside this. Listen. Gas එක තියෙන්නේ මෙතන. Right? And from here that is not closed. මේක දිගෙත් gas එක යනවා. Gas එක මෙතනට ගිහිලා එහෙමනේ pressure gauge එක වැඩ කරන්නේ. Right? ඔහොම තමයි gas එක තියෙන්නේ. But with respect to the volume of the container, right? This is a very small tube, capillary tube, right? To minimize the percentage error. Right? එහෙම නැත්නම් දැන් මම මෙතන volume එක මේකනේ heat කරන්නේ. Because we are going to heat this gas. When Bunsen burner is heated, liquid can water around the burner will be heating. When water gets heated, because of the thermal conductivity of this glass here, gas inside is going to get the heat because of the thermal conductivity. නිකන් ඒකට heat එක එන්නේ නැහැ. ඒ කියන්නේ thermal conductivity එකේ. ඒතර මේ gas එකනේ දැන් heat වෙන්නේ. Right? And this gas is not going to get that direct heat from this flask. මේ flask එක වටේට මේක heat වෙනවා. But මෙයාට ඒක එන්නේ නැහැ. එතන පොඩි error එකක් එනවනේ. To minimize that error, we are using a capillary tube. Right? ඊට පස්සේ මේ ටික measure කරගන්න we need a thermometer. Right? We need a thermometer. And to make sure there's a uniform distribution of temperature, we need a stirrer to stir this. Right? Simply ඕක තමයි කරන්න යන්නේ. එතකොට constant volume is assured because of this setup. Right? මේක leak වෙන්නේ නැහැනේ. මේකට මම gas add කරන්නෙත් නැහැනේ. So constant volume is assured. Constant volume එකක් තියෙනවා. Then to change temperature, right? To change temperature, we have the burner. Right? Making අපි temperature එක change කරනවා. By changing temperature, then we are going to get the respective reading for pressure using the pressure gauge. Right? Simple වැඩක් කරන්නේ. මෙතනින් temperature එක change කරනවා. Right? Say we are changing 10 by 10. සාමාන්‍යයෙන් අපි මේක 10 by 10 වගේ change කරනවා. Right? Starting from 25 වගේ start කරනවා. 25. Then pressure is measured. At 35 again, pressure is measured. 45 again, pressure is measured. Right? Temperature එක control කරන්න එහෙම දේවල් තියෙනවා. ඒවා කතා කරමු. But basically what we are doing is when this is heated from this, water around is getting the heat, right? Then that is taken by the gas inside because of the thermal conductivity of glass here. That's a thin glass, right? ඒකත් conductivity එක වැඩි කරන්න හින්දා thin glass එකක් කරන් තියෙනවා. Otherwise thermal conductivity decreases, no? Right? If the distance or the thickness increases, right? එහෙම කරලා මේ reading එක ගන්නවා. or reading එක අරගෙන we are going to record this temperature against pressure and then we can plot a graph. Right? Temperature against pressure දන්නවනම් graph එකක් අඳින්න පුළුවන්. Right? If this graph goes through origin, pressure law is verified. Right? Simple experiment එකක් කරන්න. Right? හැබැයි මේක එක precautions එහෙම තියෙනවා. ඔය ටික තමයි ටිකක් වැඩිපුර කතා කරන්න තියෙන්නේ. Right? There are many precautions to take into consideration when we do this. Right? Because we are doing this, even though that's a simple thing, we are doing this inside some kind of restrictions. Right? Get pොඩි restrictions තියෙනවා. Right? ඒ ටික මොනවද කියලා බලමු. Right? Then මේක ලියාගත්තා. Write down materials and apparatus. 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 Right, mention one by one. Mention a beaker, a beaker filled with water, a beaker filled with water. Right, Malayalam. Materials and apparatus. A beaker filled with water. A beaker filled with water. Right. Then pressure gauge. Pressure gauge. Then round bottom flask. Round bottom flask. Right. Then thermometer. Starter. Burner. Right, burner ke liye kena Bunsen burner. Bunsen burner. Right. Tripod or stand. Tripod or stand. Right. And other than that, a square net, or that is called a square goes, right, to put here. Right. A square goes or net to put here because now Bunsen burner has a single flame. No? When it has a single flame, that is going to point to a single point. When it is point to a single point, this bottom is going to heat by a single point. Right? To have a good distribution, we are going to use a net here to distribute heat. Net එකක් දානවා. ඒ කියන්නේ මේකට මෙහෙම net එකක් දානවා. මෙහෙම net එකක් දානවා. net එක දැම්මම පස්සේ now along the net heat is distributed. Then bottom is going to heat uniformly. Right? ඒ වැඩේ කරේ නැත්තම් මෙයාගේ අර center එක විතරක් heat වෙන්න ගන්නවා. Right? එතකොට අපිට uniform distribution එකක් ගන්න අමාරුයි. බැරි නෑ ඒක අමාරුයි. Right? So therefore මේක heat තව experiments වලත් අපි මේ වැඩේ කරනවා. Right? When we need to get a uniform distribution along this base, right? We are laying a net there. That's called a net or a gauze, right? A square net or gauze. Next one, square net or gauze, right? Right. Then, as the next heading, write down method, method, method. Method. Right. Now, let's label this as well. Make a label label pressure gauge. Pressure gauge. Make it right? And thermometer. Label this while you are drawing thermometer, beaker, Bunsen burner, stand or tripod, square net, stirrer, round bottom flask. Right. Take down the apparatus. එනකෝ වරක් වුණා. Right. Right. Check this again. Square net. Right. නැත්නම් wire gauge කියලා කියනෝනේ. Square gauge කියලා කියන මොකක් හරි. Square net. Bunsen burner, tripod, beaker, thermometer, round bottom flask, stirrer, pressure gauge. Right. And these are capillary tube. මේකත් දාගන්නවා. These are capillary tube. These are capillary tube. Capillary tube. Right. දැන් කරන්න දෙන්නේ මේකයි. We are starting from a temperature, and when we decide the initial temperature, right, usually we don't start with the room temperature, because if we start with the room temperature, now how many readings we need minimum to plot a graph? Minimum, what's our minimum standard? 6, right? 6 ne? Minimum standard is 6. So minimum අපිට 6 readings ඕනේ. Say we are starting from 30 වලින් start කරොත් 6 readings අරන් ඉවර වෙද්දි 80 90 වගේ temperature එකක යනවනේ, right? So රෝග පොඩ්ඩක් විතර control කරගන්න, what we do is, right, we'll first going to reduce the temperature by adding ice, and going to reduce this up to 24 25 somewhere around, right? එතකොට distribution එක ගන්න ලේසි. නැත්නම් distribution එක ගන්න බැරි වෙලා if we are going to exceed 100, right, then 100 වලදී මට මේක කරන්න බෑනේ, because at 100 water is going to vaporize, right? So 100 වලට කලින් we have to stop the experiment before 100. 30 වලින් start කරත් still we have the limit of 6, right? හැබැයි මොනවා හරිලා අපිට 7 ගන්න ඕන, ඒක 100 උණු කරගන්න බෑනේ. Then to be safe, right, as a precaution, what we do is we are starting with somewhere above dew point, somewhere below room temperature, right? Dew point එක ගැන idea එකක් ගන්නවා මුලින්ම. Dew point එක, let's say now today's dew point is 22, right? 22 නම් 23 වලින් start කරන්න. If the dew point is 22, we are not going to start at 23, right? දෙකක්වත් අඩුම උඩින් තියෙන්න ඕනේ. Then if there is 22, minimum 24 25 වගේ value එකකින් start කරනවා. Right, පොඩ්ඩක් හරි අර පහළ වැලිව් එකට එද්දි distribution එක ගන්න ලේසි. Right. Write down in point form. First point. Right. Write down 6 readings. Yes, good. Write down first point. set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Set up the apparatus properly as shown in the figure. Second point. At some ice, adding ice කියන එක compulsory නෑ, but that is a precaution we take, right? At some ice, to reduce temperature, to reduce initial temperature. At some ice, to reduce initial temperature. At some ice, to reduce initial temperature. To have a good distribution, to have a good distribution, to have a good distribution of readings, to have a good distribution of readings. Right. Next point. Heat water beaker using burner while stirring well. Oh, nanti kan apa? Ini keran ya kan? Stir එකෙන් කරන්නේ ඉතින් ඒක. Right? Next point. Record pressure from pressure gauge. Record pressure from pressure gauge. Record pressure from pressure gauge. When increasing temperature, for each 10 degrees Celsius, for each 10 degrees Celsius, for each 10 degrees Celsius. And record them in following table. And record them in following table. Right. Table එකක් කියලා ලොකු එකක් නැහැ. Right. We have temperatures. Right. Right. මෙතන තියෙන thermometer එකක්නේ. Thermometer is measured. Right. Thermometer measures the temperature in degrees Celsius. Right. එතකොට මෙතන අපේ direct reading එක Celsius temperature එකක්. Direct reading is going to be Celsius, but we are going to plot the graph with a Kelvin temperature. Kelvin වල convert කරලා ගන්න ඕනේ. Right. Then this is the thermometer reading. Right. Temperature in degrees Celsius. Right. Temperature in degrees Celsius. Right. මෙහෙම readings එක ගන්නවා. Like this. Then convert this to kelvins. Temperature again in kelvins. Right. And the respective pressure. මේ readings එක විතරයි අපිට ඕනේ. Pressure P. Right. Say we started from 25, then 35, 45, 55, 65, 75. මේ වගේ ගන්න. Right. මට දැන් සවර් reading එකක් ගන්න වුණොත් it is going to 85 නෝ. Right. අර ඒතකොට 15 තියෙනවනේ 100 දින. We are within the limit. නැත්නම් නිකන් අර 90 95 වගේ reading එකකට යන්න ගියොත් ඒක අර එච්චරම success නෑ. Right. ඒකයි අර ice දාලා මුලින්ම මේක අඩු කරේ. ඒක precaution එකක්. හොඳේ. Not compulsory but a precaution. Right. මේක දන්නවා නම් we know Kelvin values, pressure gauge එකෙන් ගන්න මේ reading එක. Right. Then we have Kelvin temperature with pressure. Right. Can plot a graph. ඊට පස්සේ කරන්නේ we are going to plot the graph. Table එක ලියා ගන්න. Take down the table. Adding IC is optional. Yes, that is optional. That is optional. That is optional. 30 wheeling start කරන්න පුළුවන්. That is doable. But to have a good spread, මට නිකන් readings 8ක් විතර ගන්න පුළුවන් නම් තව හොඳයි. That is better if you can have more readings, right? අන්න ඒ වගේ scenario එකක් ආවොත් that's better to decrease temperature no, right? එතකොට නිකන් 24 25 වගේ level එකකට high set කරලා මේවා කරගන්න පුළුවන්. That is optional. Right, next point. Plot the graph. Plot the graph between pressure and volume, between pressure and temperature, pressure and absolute temperature. Plot the graph between pressure and absolute temperature. Right. When the graph is pressure and absolute temperature, right? By marking these points, got this graph. Right? Right? Then conclusion. If the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is, if the graph between pressure and absolute temperature is a straight line goes to origin, 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 pressure law is verified. Pressure law is verified. Pressure law is verified. Right? මේ තියෙන pressure law එකනේ. Right? අපි ලේසියට කියන්නේ ඉතින් මේ pressure law එක. This is the pressure law. Pressure law is verified. Right? Okay. Basically කරන්නේ මේ වැඩේ. Right? But there are some other facts to put some attention on and put some extra care, because there are some, as I told you, there are some like restrictions and some other points to be careful, right? Right? Write down as remarks. Right, first thing, listen. When we heat from a Bunsen burner, right? When we heat from a Bunsen burner, right? This heat is not immediately going to acquire by the gas. No? It takes some time. Heat gas heat then initially this heat should be acquired by the square net here, and then by conduction this beaker here, right? Then after that beaker, that heat is acquired by water inside, right? When water is heated, now when we stir this properly, it is uniformly distributed. When water is heated only, this round bottom flask is getting the heat, right? Then again, through a heat conduction through these walls of the flask, only gas is getting the heat, right? So, heat heat again. That is not instant. right? මෙතනින් heat කරපුවා මෙතනට ඒක වෙන්නේ නැහැ. right? මේ temperature එක වෙන්නේ නැහැ නේ. මෙතනින් heat කරපුවා. Then what we do is this. Say I need to get the temperature at 25, right? What we do is right, you can't stop this exactly at 25 when we heat this from a Bunsen burner. ඒකම control කරන්න බෑනේ මේ Bunsen burner එක කියන්නේ. නිකන් පත් වෙනවනේ යටින්. This flame is here, right? And even though you remove this, now when this is at 25, it is going to increase the temperature more than 25. Hey, making up heat එක තමයි මෙතෙන්ට ආවිලා නැහැ. Got the point? When the temperature shows, when the thermometer shows a temperature 25, right? If you remove this until you take the measurement, right? That temperature is not going to stop at 25. That is going to rise above 25 because even though you remove this at 25, there is another additional amount of heat that is not acquired by the gas. ඒක instantly වෙන්නේ නැහැ. ඒතර ඕක තවඩයක් උඩට යනවා. Right? To minimize that error. ඉතින් error එකක් එනවනේ. Right? As a precaution, what we do is we heat this to a point where around 2 degrees above to the expected value. Right? 25 නම් මම ගන්න යන්නේ. මේක heat කරනවා 27 වලට. Then we are removing the burner. Flash නෙමෙයි. Removing the burner. Burner එක අයින් කරනවා. burner එක අයින් කරාට පස්සේ ටික ලාගෙන temperature drop වෙනවනේ. When it drops, we can easily catch where it is going to reach 25 now. Increase වෙද්දි හොයන්න බෑ. ඒ යටින් heat එක දාලානේ තියෙන්නේ. ඒතර මඩේ control කරන්න බෑ. But when it slowly drops, then it is going to stay at 25 for a little bit longer than this. අන්න ඒක තමයි reading එක ගන්න time එක. ඒක තමයි precaution එක. ඒතර 25 ගන්න අපි මේක 27 වලට heat කරලා මේක අයින් කරනවා. That is one thing. Right? නැත්නම් අර නිකන් temperature එක අපි set කරලා වගේ නිකන් program කරලා වගේ එහෙම ගන්න බෑනේ. You are going to do this manually. Right? We are doing this manually. 25 වල මට control කරගන්න විදියක් නැහැ. ඒකට තියෙන precaution එක අරක increasing the temperature up to 27, 2 degrees above the expected temperature. ඔයා 30 නම් ගන්න 32, right? එහෙම. 2 degrees above the temperature and removing the burner and let it cool down up to that point, right? So when it cools down to that point, then only you are going to read the reading from the pressure gauge, right? අර නැත්නම් අපිට කැමති තැන ගිහිල්ලා මේක stop කරන්න බෑ. point එක තේරුණාද? Right? Because when thermometer shows a temperature 25 when you heat, right? Temperature inside the system is not actually 25. That's a delay it has, right? මේ හරිය එතකොට 25 නෙමෙයි. මෙහෙ 26 විතර වෙලා. හැබැයි මෙයා පෙන්වන තාම 25 කියලා. මේ හරිය heat එක වැඩි. ටික වෙලාවක් යනවා මේක වැඩි වෙන්න. right? ඒතර burn එක ගාව ගත්තොත් මීට වඩා වැඩි. right? That's the thing. ඒතර immediately මේක 25 වෙද්දි gas එක 25 වෙනවද? එහෙම වෙන්නෙත් නැහැ. It takes a time. right? ඕක තමයි case එක. ඒතර මේක පොඩක් slow කරගන්න ඕනේ. Increasing it to 27 and let it cool up to 25 and then only you are taking the reading. Right? First point, write down. මේ remarks වල කියන points එක තමයි especially questions වලට එද්දි ඕන වෙන්නේ නේද? Because in questions always you will be asked about these special things, important things about the experiment, no? Right? Precautions, other important things, right? Those things extra care we take, right? ඒ ඔක්කොම තියෙන්නේ මෙතන. මේ ටික very special ලා. නැත්නම් method එකේ තියෙන ටික that's more or less the normal. ඒක normal නේ. ඔයා වෙන කොහෙන් හරි මේක බැලුවොත් ඒක normal. හැබැයි මෙතන තියෙන ටික අනිවාර්යෙන් දැනගෙන ඉන්න ඕනේ. Plus that will be question when comes to a question, right? First one, write down. First point. When a reading is taken at a certain temperature, it should be heated around 2 degrees Celsius above around 2 degrees Celsius. It should be heated around 2 degrees Celsius above the expected reading. Above the expected temperature, Gillian. Above the expected temperature. 2 degrees Celsius above the expected temperature. And then burner is removed and then burner is removed to control heat, and then burner is removed to control heat. For the same point, when the system cools down again, when the system cools down again, when the system cools down again to required temperature, take the reading of pressure gauge. Take the reading of pressure gauge. Right. Next point. Right. Next point is about stirring this. Listen. Now, if you didn't stir well, right, what happens is uniform distribution of temperature is not going to get by the whole liquid or the whole amount of water, all the molecules of water, right? Then when you stir this well only, uniform heat is distributed in all volume of water. Then only these walls are getting a uniform heat, right? Temperatures, right? To control this throughout the experiment, stirring this is mandatory, right? Then අපි ඔක් කරද්දී තනියෙන් කරන්න ගොඩක් වෙලාවට අමාරු වෙන. ඒතකොට එක්කෙනෙක් ඕක වෙනම ස්ටේ කරන්න තියෙනවා. ඉතින් කර කර ඉන්න. මොකද ඒක කන්ටිනියුස්ලිම කරන්න ඕන. ඒක ස්ටොප් කරොත් ප්‍රශ්න වැඩි කියන්නේ මේ වැරදි. It's erroneous. Right? Second point. Stirring well throughout the experiment is mandatory. To ensure a uniform distribution, of heat throughout water beaker. To ensure a uniform distribution of heat throughout water beaker. Right? Next. Listen. Now, this is going to get heat through heat conduction through this glass, no? Then having a thin flask is very important, right? If the flask is not thin, glass is not a good heat conductor. Glass කියන්නේ කොහොමද heat insulator එක. Glass කියලා කියන්නේ හොඳ heat conductor එකක් නෙමෙයි. That is a heat insulator, right? Then to minimize that impact, we have to have a minimum possible thickness for the flask, right? ගොඩක් කීනි flask එකක් use කරන්නේ නැත්නම් මොකද glass කියලා කියන්නේ glass එකක් use කරන්න නැතුවත් බෑ, right? මොනවාද copper වගේක් use කරන්න බෑ. glass එකක් විතරයි use කරන්නේ. හැබැයි glass කියලා කියන්නේ that is not a good heat conductor. ඒතර ඒක minimize කරන්න විතරයි පුළුවන්. We can't make it zero. Minimize කරන්න ඕන නම් කරන්න තියෙන්නේ. We know heat conduction is QOD equals Ka delta theta OD, no? Right? So higher the thickness, lesser the conduction, right? Then what we can do is choosing a flask with a minimum thickness to increase this, right? Take a minimize කරන්න විතරයි පුළුවන්. Next point, write down. Having thin walls for round bottom flask is important to increase heat conduction, to increase heat conduction, to increase heat conduction from water to gas inside flask, from water to gas inside flask. Right, next thing. Listen. So I told you this is a capillary tube. This is a capillary tube. Right? Now the thing is this capillary tube and the gas inside capillary tube is never going to get the temperature of the gas here. මේ temperature එකට මේක කවදාවත් equal වෙන්නේ නැහැ. කොච්චර මේක heat කරා. එහෙම කරන්න බෑ. Right? Then only thing we can do is minimizing this to minimize percentage errors. Right? So therefore we are using a larger flask with a capillary tube. Then with respect to the volume of gas here, right? If this is a negligible volume inside the capillary, it can be neglected, no? If that percentage error is less than 1, එතකොට තියෙන volume එකේ percentage error තේරෙනව නේද? Right? To have a percentage error less than 1%, right? නැත්තම් එහෙම මේක consider කරන්න වෙනවනේ. If the percentage error is less than 1, we can neglect it. Right? ඒක අපේ allowed limit එක. That is 1%. 1 එකක් නම් allowed අපිට අයින් කරන්න පුළුවන්. Then what we do is we are choosing a capillary tube here as to minimize the percentage error. Right? Then we will neglect the percentage error, but we are neglecting by being inside our limit. That's the thing. Right? Then ලොකු tube එකක් දාගෙන ඒක neglect කරන්න බෑ. Right? With respect to the volume inside the flask, this should be negligible. Right? To serve that purpose, the capillary tube is used. Right? Next point. Volume of gas inside capillary tube. 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 Should be negligible with respect to the volume of, should be negligible with respect to the volume of should be negligible with respect to the volume of gas inside flask. Should be negligible with respect to the volume of gas inside flask. Right? Within brackets, to minimize percentage errors. Within brackets, to minimize percentage errors. Right? Okay, then the reason to use a round bottom flask is this. Right? We know minimum possible area is taken for same dimensions, right? When something is spherical, no? Right? Our example එකක් තමයි water bubbles or water droplets in surface tension. Higher the stability means lesser area, because surface energy is given by delta AT, no? Delta AT. Lesser area means higher stability. Right? Then to lessen the area, naturally those things are spherical. Right? So මේක නිකන් ඔන්න මෙහෙම ප්‍රූව් කරන්නත් පුළුවන් දන්නේ නැත්තම්. Right? නිකන් radius එක r තියෙන 2r කියමු. 2r තියෙන sphere එකක් ගන්න. What is going to be the area here? Area of this one 45r 45 නෙමෙයි 85r 8 නෙමෙයි 2r, no? This area is A1 45r squared, then 2r squared. Right? මෙතනින් එනවනේ 16 5r squared කියලා. Right? මේ dimensions में තියෙන, say you are getting a cube. Right? නිකන් මේක check කරලා බලන්න. 2r. Right? මොකද දෙන්නේ? 24 නේද? 4 into එහෙම නෙන්නේ. මෙතනින් එන්නේ 8r squared. Right? Sorry, 2r නෙමෙයි මේක r නේද? Same dimensions means width එක same වෙනවා කියලා කියන්නේ diameter should be 2r. නැත්නම් මට compare කරන්න බැරි වෙනවා. diameter is 2r මේක r එතකොට 4 5r squared මන් නිකන් බලන්න මේක comparison එකක් කරලා 4 5r squared ඊට පස්සේ ආයෙ මේක සිලින්ඩර් එකක් එක්ක ඕන සිලින්ඩර් එකක් එක්ක compare කරන්න right මේක 2r වෙන සිලින්ඩර් එක right එළියුවත් මේකට වඩා වැඩි එකක් එනවා right this is going to be 5r squared into 2r right 5r squared into 2r 2r sorry 2 5r squared plus 2 5 2rh 2rh කියලා කියන්නේ again 2r right මේ අනේ සිම්පල් කරලා බලන්න මේ හැම එකක්ම මේකට වඩා වැඩි right then minimum possible area is going to get area සිම්පල් කරගෙන ඉන්න ඕනේ minimum possible area is for spherical shapes right when the area is minimum right we can easily heat this මේ area එක ගොඩක් වැඩි නම් ඒක heat කරන්න අමාරුයි right so therefore spherical means round bottom flask is used spherical flask are used right diagrams හඳින්න ඕනේ නෑ මම point එක කියන්න write down next point to minimize the area to minimize the area to minimize the area to minimum possible value for same dimensions to minimum possible values for same dimensions to minimum possible value for same dimensions to minimum possible value for same dimensions a spherical shape slash round bottom flask is used slash round bottom flask is used right next thing about this about using the square net right a point එක මම කලිනුත් කිව්වා when the square net is used only we can uniformly distribute the heat coming from Bunsen burner right throughout the bottom of the beaker right otherwise the flame is going to point to one point at the bottom of the beaker right next point a square net is used to uniformly distribute heat throughout the bottom of beaker without being pointed to a single point right next thing right I gave you this point when we are discussing about thermometers right thermometers වලදී කිව්වා verification of pressure law and the setup means මේ setup එක හරියටම මේක නිකන් මොන thermometer එකක් වගේද මේක අපි දන්න thermometer එකක් what is it this is a demonstration of a popular thermometer we have how many gas thermometers we have two මොනවද මේ දෙක constant volume gas constant pressure gas right මේ දෙන්නේ මොකද constant volume gas thermometer එක right then what are the gases we are going to use here in this ඒක මම එතෙන්දි කිව්වා in thermometry what are the possible gases to be used in a constant volume gas thermometer helium neon right helium neon වගේ තමයි use කරන්නේ then most popular one is helium වගේ තමයි use කරන්නේ helium or neon right because they are less reactive right next point ඒකන idea එකක් තියෙන්න ඕනේ next point Gases such as hydrogen, helium or neon. Gases such as hydrogen, helium or neon. Hydrogen, helium or neon are used since their behavior is much closer to that of an ideal gas. Is much closer to that of an ideal gas. It is supposed to be ideal because these equations are valid only for ideal gases, right? Within brackets, write down. But helium is used more popularly. Understood conditions. Right? Next point. Ice can be added to water initially to reduce initial temperature below room temperature to have a better spread of values in the graph. Right. Next thing. Now, there's another one we have neglected. Right. In terms of thermal, what is it? Then now we are heating something. Then, when any substance is heated, it is going to expand. Right? Which means now over time, this flask is also going to expand. Right? That expansion should be negligible. Expansion එක මෙෂර් කරන්න විදියකුත් නැහැ. Right? එතකොට දැන් මම මෙතන constant volume කියලා කිව්වට is it a constant volume? No, that is going to expand by a little bit. But that expansion should be small enough as to neglect. Right? So therefore, in glasses also, there are different glass materials with different expansivities. No? Then when this round bottom flask is made, a glass with minimum coefficient of expansivity is used. Right? එතකොට නිකන් අපි ගෙදර තියෙන glass එකක් වගේ මේකට හරියන්නේ මේක lab එකේ තියෙන instrument යන්නේ. Right? Then for that material, a type of a glass with a minimum expansivity is used. Right? It must be used. Otherwise, if this expansion is considerable, right, we are never going to get a graph which goes to origin. Right? So volume එක change වෙලා තියෙන volume එක change වෙනවා කියන අර graph එක මේව straight line එකක් එන්නේ නැහැ. ඒතකොට ඉතින් කොහොමද experiment එක කරලා තියෙන්නේ? There are errors we make. ඒකයි මම කිව්වා we have constraints තියෙනවා. මේක නැති කරන්නත් බෑ. Then only thing we can do is using a flask with a minimum coefficient of expansivity. Right? වෙන options නැහැ. වෙන කිසිම option එකක් නැහැ ඒක නැති කරන්න. ඒක 0 කරන්න බෑ කොහොමද? Right? Minimizing විතරයි කරන්න පුළුවන්. ඒකත් 0 කරන්න බෑ. Right? Next point. Flask should be made with a glass of minimum thermal expansivity. right? Next about hygrometry. Case when we inside the gas into this, right? If we are to include water vapor with that including gas, right? Water vapor is not going to behave as an unsaturated vapor, right? Gas laws are only for which gases? Point. Gas laws valid only for unsaturated gases, right? Then if a water vapor is going to be inside, water vapor is going to be saturated, right? If saturated, variation pressure of a saturated gas is different from the variation of a unsaturated gas, right? Then we have to make sure that this 100% volume is filled with a dry gas, right? 100% is filled with a dry gas, right? Everything fill කරද්දී වෙන්නේ මේක අපි නෙමෙයි fill කරන්නේ. This setup is there. ඒ කියන්නේ මේක අපිට fill කරන්න බෑ. අපි නෙමෙයි helium fill කරන්නේ. setup එක තියෙනවා. ඒතර මේක seal කරලා තියෙන්නේ. seal කරලා තියෙන්නේ මේ setup එක මෙන්න මේ ඔක්කොම ටික seal කරලා තියෙන්නේ. right? ඒතර ඒක එතෙන්දි වෙන්න ඕන එකක් at the point of filling this, right? You have to make sure that 100% dry gas is inside. Otherwise, it is going to saturate at some point, and the ultimate impact is that is going to be erroneous, and pressure law cannot be verified if there is a saturated part inside it. If there is a saturated part inside it, right? Next point. Next point. Gases laws are valid only for. 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 Gases laws are valid only for unsaturated gases. Unsaturated gases. Unsaturated gases. Unsaturated gases. For the same point. Therefore, total volume inside flask should be filled with a dry gas. Should be filled with a dry gas. Should be filled with a dry gas. Right. Then, look at here. Without using this pressure gauge, right? Pressure gauge එක තමයි අපි use කරන්නේ, but there is another alternative if we are not using a pressure gauge, right? Alternative එකක් තියෙනවා. Our experiment is supposed to be done using the pressure gauge. හැබැයි මේකට මොකක් හරි තව alternative එකක් තියෙන නිසා මම මේ කියලා දෙන්නේ. හදිස්සියට ඇහුවොත් මේක ගැන. Right? If it is going to be questioned about the alternative is this. Alternative is this. Right? මේ alternative එක ගැන මම thermometry වල කිව්වා. කිව්වා නෙමෙයි අපි මේක තමයි යන්නේ ඇත්තට. Without using the pressure gauge, right? We can use the same setup here that we had in the thermometer. Right? This should be filled with mercury. Right? මේක alternative එකක් විතරයි. Right? This should be filled with mercury. Right? මේ part එක අන්ද මතකයිනේ අපි thermometry වලදී. Right? මේකේ readings තියෙනවා. Right? මෙන්න මේක මම ඇදලා ඇද්දා. Right? And this part is a rubber tube. මේක rubber tube එකක් හින්දා මේක පොඩක් move කරන්න පුළුවන්. This is actually a rubber tube. Right? මේක rubber tube එකක්. And cross check this again with the constant volume gas thermometer. Right? ඒක මේක ඇඳලා ඇති. Now here we have an indicator. මෙතන indicator එකක් තියෙනවා. එහෙමනේ අපි constant volume එක තියාගත්තේ. Same thing. මෙතන තියෙන indicator එකක්. Some mark is marked here. මෙන්න මෙතන mark එකක් ගහලා තියෙනවා. Right? Then always when you take a measurement, we have to make sure that this surface of mercury is at this mark. If there is at the mark, which means constant volume is inside, no? Right? To take the pressure reading, we have this height here. මෙතන ගහලා තියෙන මේක scale එකක්. This is h. Then this pressure difference is h rho g. Right? මෙහෙම කරලා අපිට improvise වෙන්න පුළුවන්. Right? Without using a pressure gauge. right pressure gauge එක use කරලා තමයි කරන්නේ මම ආයි කියන්නේ ඒකයි pressure gauge එක use කරලා කරන්නේ but this is an alternative you can do right හදිස්සිය හරි මේක නිකන් modify කරලා මෙහෙම එකක් දුන්නොත් confuse වෙන්න එපා pressure එක ලියන්න වෙන්නේ P0 plus h rho g that's it P0 plus h rho g එක ලියන්න හරිනේ next point following setup can be used instead of following setup can be used instead of using the pressure gauge following setup can be used instead of using a pressure gauge right setup එක මදින්න ඕනේ just draw the modified part right මෙන්න මෙතනින් පස්සේ flash එකත් එක්ක modified part එක විතරක් අඳින්න ඕනේ setup එකම ඕනේ right setup එක අඳින්න පුළුවන් නම් එකක් ගන්න නැහැ but setup එක ඕනේ mercury right මේක open this part is a glass tube this is a rubber tube right ඊට පස්සේ මෙතන තියෙන්නේ it's a meter scale meter ruler or the scale right finished හරිනේ මේ මෙතන තියෙන ඉන්ඩිකේටර් එකක් right indicator එකක් කියලා කියන්නේ මෙතන පොඩි mark එකක් තියෙන this mark mentioned here right to make the volume constant ඒතර මේ mark එකට අපි ගෙනලා තමයි readings ගන්නෙ right this is an indicator right write down below this setup again vertical height of mercury column should be obtained vertical height of mercury column should be obtained vertical height of mercury column should be obtained in order to find pressure at a given temperature in order to find pressure at a given temperature right okay right so basically that's it for this experiment right even though we are doing something very simple right අර methods ඔක්කොම වඩා remarks වල මම කියපු facts වැඩිනේ ඒක මම කිව්වේ දැන් මේකේ method එක lazy but we have some part of few restrictions ඒ restrictions ගැන questions ආනවා ඒතර ඔයයක් ඒකේ දැනන් ඉන්න ඕනේ right so even though the method is very simple method is very straightforward and simple මෙතනින් heat කළා pressure එක ගත්තා ගේජ් එක තිබ්බනම් වෙන මොකුත් කරන්න දෙයක් නැහැ. හීට් කරනවා, හීට් එක තියෙනවා, ගේජ් එකෙන් ප්‍රෙෂර් එක ගන්නවා. And plotting a graph, right? But we have some restrictions, no? So we have to be careful and we have to be within those limits, right? And the restrictions properly to minimize all the errors that we discussed so far, right? And do the experiment, right? Okay, so that's it for the first one. Any questions from this one? Any questions from experiment one? Any questions from experiment one? Right? මේකෙත් බලන්න තියලා දෙන්න ටික ඕන. Right, so only point given under note here is මේ තියෙන guide එකේ it's only about the capillary tube, right? Capillary tube එකේ මත තියාගන්න, right? Other than that there are many more facts to be considered. Be careful when you do the experiment, right? මේක තියෙන the temperature of the water in the heater should be raised very slowly and the water should be continuously stirred. And since the temperature of the air in the tube connecting the bulb and the gauge and the temperature of the air in bulb do not exist at the same value. Right? These two are never going to be gauge these two are never going to be same. Then only thing we can do from our side is minimizing it. Right? To minimize it, the only option we got is using a capillary tube. To minimize the percentage error of this volume you are going to consider. Right? Right, මේක තියෙනවා මේ point එක and the temperature of the bulb it's going to the same value. The resulting error can be minimized by using a bulb with a large volume and a capillary tube as a connecting tube. Right, ඒ percentage error එක 1% වල අඩු කරන්න විතරයි අපිට පුළුවන්. වෙන option එකක් නැහැ. Right, any questions before moving on to the next? All good? Adding ice adds optional. Sir, would you mind explaining some more details around the topic? I think you sent it before I explain, right? What happens to the graph if it's drawn in degrees Celsius? Can be drawn in degrees Celsius, right? But not as easy as to identify as it is going through origin, no? That's the thing, right? එහෙම වුණොත් එහෙම intersection එක එන්න ඕනේ intercept එක එන්න ඕනේ at minus 273, right? Well, you can get a scale එහෙම අඳින්න පුළුවන් බැරි නෑ, right? But difficult. You have to have a proper scale. So scale එකේ තියෙනවනේ දැන් say you are drawing 10 by 10, then you have to check the intercept where it is going to intersect that point at minus 273, right? ඒක හිතන තරම් ලේසි නෑ. ඊට වඩා අපිට origin එක intersect කරන එක ගොඩක් ලේසියිනේ. That's why absolute temperature is used, right? Otherwise we can't say we can't plot the graph with relative temperature. Possible, right? But a little bit difficult. Will the reading decrease once we remove the thermometer, sir? We don't remove the thermometer. We remove the Bunsen burner. Man thermometer remove කරන කියලා ඈ. We don't remove the thermometer. ඒක කොහොමද තියෙන්න ඕනේ? We don't remove the thermometer. Remove කරන්නේ Bunsen burner එක to control flame, to control heat, to control flame. The pressure gauge alternative equation. Pressure gauge alternative equation. P naught plus H rho G. Pressure එක යෝනේ. P naught plus H rho G. All good. Right, what else? Anything else? Anything else? it's by mistake. Yeah, ඒක තමයි. තර්මීට එක රිමූව් කරලා කොහොමද ටෙම්පරේචර් රීඩින් එක ගන්නේ? Very well explained. Right, okay. Then we move on. Right. Okay, all good. Anne, let's move on. Listen, when it comes to thermal practicals compared to other practicals, right, we have comparatively more details in thermal. අනිත් ඒවා වගේ නෙවෙයි. thermal වල පොඩ්ඩක් details වැඩි. Right? So we have 6 experiments only, right? But they have more details. They have more details. ඔය mechanics එක්ක waves එක්ක වගේ compare කරත් එහෙම ඒවා පොඩි පොඩි practicals එකකට කියනවා. Right? මේක details වැඩි. Then when you study these things, put some more attention and do it. And now just after today, right? Best thing is just after today, make sure you are getting this, you are grabbing this then and there and practice other questions starting from tomorrow, right? මම paper class එකේ නම් මේ questions කෙනෙක් කරන අතර discuss කරා, right? දැන් second එකේ තියෙන එකත් method of mixtures solids paper එකේ තිබ්බනේ නේද? තිබ්බනේ? ඒක මේ මම papers වල දිගටම දැම්මා, right? As a seminar we are doing this, we are discussing this today, right? මම paper discussions වල discuss කරලා තියෙන experiments මෙතන තියෙනවා, right? අයම නෙමෙයි, but method of mixtures ඊට පස්සේ law of cooling ඔය වගේ ඒවා paper discussions වලත් මම discuss කරලා තියෙනවා, right? So let's move on, right? So එතකොට මේක කෙලින්ම අදම ඉවර කරන්න ඕනද? බොමුද සීතල වතුර විදුරුවක් කියලා හරි තින්නේ සීතල වතුර විදුරුවක් තමයි මම බිව්වේ. Right. Second one.